All right, so bunch of things going on this week. So today I want to talk a little bit about the flowcharting homework, right, and just sort of make some general comments on flowcharting. And then I want to talk about another way to input information into a shell script. So this business of command line arguments versus runtime arguments. I just want to give you an example of that, and I'll open an ODP tomorrow morning that lets you work with that notion. And then I want to talk about GitLab and Git a little bit so that you can start using that as a backup system. And then we're going to spend some time working probably individually or maybe in groups of two on flowcharting for this PA1. Now some of you have already done PA1, but I'd still like you to spend some time doing some flowcharting. So we'll do that, and then we're going to move into sort of spending some time talking about C programming and just kind of refreshing, but also talking about things like doing input in particular and processing command line arguments on that. And that'll be a lead up to PA2, which will be posted on Friday. But let me start with some comments on the flowchart. So most people had the right idea for the flowcharting thing. So the goal was to print out the largest of three inputs. I did not intend you to have to do a lot of extra work if two of the numbers happen to be the same, right? My comment was, if two of your numbers are the same and that's the largest, it doesn't matter which one you print. Here's three numbers, tell me which one's largest. Well, if they're all 10, just tell me 10 is the largest. But some people did a lot of work sort of figuring out how many times that number occurred and printing it multiple times and so on. So that's fine. If you ever have an assignment and it's not totally clear what it is I'm asking you to do, please ask, right? For assignments, but also on tests. So exams are mostly writing code, and a lot of times, I'll say something like do this, and I intend it to be a few lines of code, and I'll get 3 pages of attached code because somebody thought, well, it can't be that easy, and they started thinking of all the different things I might want. Just ask, okay? And if it's a question to you, it's probably a question to some other people as well. So that's one thing. When we're flowcharting, we're really trying to sort of capture the logic of what it is that we're doing. What are the steps that we have to take in order to perform this behavior? What's the algorithm? So saying things like integer x doesn't really belong in a flowchart. Okay, that's sort of something we would do when we're writing the actual code, but this is not the purpose of a flowchart. It's not to write C in a bunch of boxes. It's to write the algorithm. And integer x is not part of the algorithm. It's part of what we have to do if we're working in certain languages. We have to say x is an integer, okay? So to some degree, less is better. So here's a big question I had, and I would say probably 80% of the flowcharts had something like this. Set I equal to 0 and then input I. Or in some cases, I saw something like this. Initialize I, and then input I. And this is clearly, to me, unnecessary. Because if I set I equal to 0, and then I say, let's read the value of I using a scanf or something, right? Why did I have to set I equal to 0? Right? All I'm doing here is I'm loading a new value into I. I don't care what its original value was. Now, initializing things is usually a good practice, right? And I'd rather you initialize when it's not necessary than forget to initialize when it is. But at the level of a flowchart, right, logically, is there a reason to set this variable I to 0 and then go ahead and input it from the user? Probably not, right? And if you don't have this in your flowchart, then when you're writing your C code, right, well, you got to say integer I because it's got to be an integer. But do you assign it equal to 0, right? That's a piece of an algorithm. If it's not in your flowchart, then you probably won't do it in your program. But this, I'm not sure what people meant by initialize I. But I saw that in like half of the flowcharts. Initialize I1, I2, I3, and then input I1, I2, I3. So it's possible that some people meant declare I, right, to be an integer. It's possible people meant go ahead and give it a value, okay? So terminology, integer I, that's a declaration. You're declaring what type of variable I is. I equals 0, that's an initialization. And you'll see those terms used throughout computer science, and so that's usually what they mean. When you're declaring a variable, you're telling the compiler, here's a variable, it's called I, it's an integer. It's an array with 20 entries, whatever. When you initialize, you're actually assigning a value, and usually it's the first value that you're assigning. So I don't know which was going on here, but that's just something to keep in mind. So there were lots of different fundamental algorithms that I saw for doing this problem. One approach that some people took was they had a variable named max, and they set that equal to 0, and that was going to be the maximum value of your 3 inputs. So they compare your first input, if it's bigger than max, set max equal to that input. Compare your second input to max, if it's bigger, set max equal to that, and so on. There's a problem with this, though. Anybody know what the problem is?
Bunch of negative numbers.
Yeah, if you put in 3 negative numbers, it's going to say the largest number is 0. So in general, unless we say otherwise, when we say integer, we mean any integer, positive, negative, or 0. Okay, and effectively as large as possible. It's really 2 billion to minus 2 billion if it's 32 bits. But when you say integer or number, don't just think positive, okay, and don't think non-zero. Okay, it could be anywhere, and it's kind of a special case, right? If all your numbers are negative, this won't work. So how do you get around this? Well, one way would be to start off with max equal to your first number, and then compare your second number to max, and if it's bigger, set max to that, and then compare your third number to max, right? And now you don't have some special magic value because you know that this is possibly the max. Some people wrote a sort algorithm to sort the 3 inputs into smallest, middle, and largest, and then printed out the largest. That's okay, extra work, right? On a test, probably not something you want to do unless you're really fast at that particular algorithm, okay? But it perfectly works, right? I saw things like this. Input equals X. And we don't really have a particular syntax for how to say we want to read input from the user. But typically, when we write this equals sign, we think of it as an arrow pointing to the left. That's just kind of convention. So if we say input equals X, it looks like we're taking the current value of X and somehow setting input equal to that. So I would prefer to see this like X equals input. And we think of it as take the input, assign it to X. And similarly, if you want to set X equal to X plus 1, we write X equals X plus 1. Don't write this, because that's going to be confusing to most people, right? This makes sense if we think of the equal sign as pointing to the right, take X plus 1 and assign that to X. But that's just backwards from how most languages are written, right? So we really think of the equal sign as assigning to the left. So put the thing that you're calculating on the right, put the value you're storing it into on the left. Okay, and that'll keep things a little cleaner. Make sure you include a stop. And for various reasons, it's probably cleaner if you only have a single start and a single stop. Well, single start is obvious because there's only one place to start. But if you have 3 branches in your flowchart that all come to stop, I would put an arrow and bring it down to a single stop. Okay, that's just kind of the idea that there's a single entry point and a single exit point in any module of code. It's just a detail, but try doing that, and and see how that feels. And then the last comment is a picky one, but please use your full names on these assignments, okay? One, because I don't know all of your last names yet, but two, it's impossible to alphabetize if I just have a last initial. And I've got 65 papers I'm grading, and so anyone that has just an initial I have to put in a separate pile and wait till I'm missing someone and then try to guess if the first names match. So full first name, full last name is like the best approach, right? And if you're in a university where there's 300 students and a teacher has a paper and it doesn't have a full name on it, they're probably going to toss it, right? And you'll come to them and say, I did the homework, why didn't I get a grade? And they'll say, you know, here's your paper, doesn't have your name on it, 0 points. So just get in that habit. And that helps me out too. All right, so just to close the loop on this, here's one way to do this process. Sorry, that should be angled. And I'm just saying input A, comma B, comma C, right? Don't just say input the numbers, right? If you're going to use those numbers elsewhere in your flowchart, you got to tell me what those numbers are stored into, right? Some people said input 3 numbers, and then they started saying if A is bigger than B, where did A and B come from, right? So do something to make it clear that you're inputting into those particular variables. So I'm just going to say input A, B, C, and I can just say is A bigger than or equal to B and A bigger than or equal to C, because we can do AND statements. And if it is, then I'm just going to print A. And if it's not, I'm going to say is B bigger than or equal to A and B bigger than or equal to C. And if it is, I'll print B. And if it's not, then the only possible conclusion is C is our biggest number. So print C. And stop. We're done. And like I say, there's probably at least 20 different algorithms I saw, all of which were correct. But every block of code, every output input statement, every conditional statement here, I can pretty easily write in a line of C or in a line of a bash script, right? You can say if A is greater than or equal to B, ampersand, ampersand, A is greater than or equal to C, curly bracket, print A, close curly bracket, right? Else, blah, 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 else, blah, blah, blah. So in the back of your mind, you have maybe a target language in mind for what you're going to eventually write your program in, right? And that can sort of affect the level at which you're doing your flowchart. You know, if I was writing this in assembly language, this is not the flowchart I would want to write. Because assembly language doesn't have something like if A is bigger than B and A is bigger than C, right? We have to take these things and do them individually and branch based on comparisons to 0 or something. So my flowchart would be much more detailed in that case. All right, so questions about that? All right, so let's talk about Git. And let's talk more generally about source code control. So you're writing a program for a class or for yourself, and it's got several files to it, right? And today you're working on this file, and you have some lunch, you come back, you work on that file, right? You make some changes, and not a problem, right? You've got everything in your head, you know which files are what and what they do and what changes you made yesterday and so on and so forth. But imagine that you're working on a project with 1,000 programmers working on thousands of different files of code, right? Maybe each programmer is working on 10 different pieces of code, and you got 1,000 programmers, and they're scattered all around the world. So at 2 in the morning when you're going to bed, somebody is waking up and they're popping onto the system and they're going to start editing their piece of code. And all of this code is part of a single system. So all of it has to work together correctly. And there's a lot of problems that start to come up. For example, I need your code to work on my piece of the system. So I grab a copy of your code and I start making changes in my system and testing. And while I'm doing that, you start making changes to your code. Now I finish my code, it works perfectly, but guess what? You change something in your code, and the next time I pull down your code and try to put it with mine, things start to break, right? Or I'm working on a piece of code, and it affects you, and you decide in the middle of the night, I think I can fix that code. And you take a copy of my code and you make a bunch of changes to it. And now other people who want to use my code get your copy of code, and everybody's developing on this new version of my code. And I come in the next day, and I make one change to my version of the code, and I give that out to everybody, and all of your changes have disappeared now, right? So these kinds of things are big problems, okay? And so this idea of source code control, being able to manage the raw source code for all the different parts and pieces of some large project, historically this has been a big problem. And as projects have grown larger and larger, and as things have become more collaborative and more dispersed geographically, right, this problem gets worse and worse. It used to be you just sort of like lean over your cubicle and say, hey, I'm going to work on module 17, is that okay? And someone would say, yeah, go ahead, I won't touch it until you're done. And you go ahead and take a copy of that, edit it, and you're done. It doesn't work anymore. So when Linux was being developed, the team was using a source code control system that managed all of this complexity for them. The idea was there was a central repository and all the code would be kept in this one place. And when you wanted to do something to a piece of code, you would check it out of this repository. And you'd make your changes, and when you were done, you'd put it back in. And while you were working on this, if somebody else came along and wanted to use that code, they would go to the repository and it would say, Nick's got it checked out right now. And they'd either wait or they'd call you up and say, hey, I need to work on this module, can you check it back in, right? And so source code control systems have been around for a long time. They work pretty well. When Linux was being developed, they were working on this open source project. So the idea was that Linux would be freely available, source code available, people could take it and do what they want with it. And they were using an open, freely available source code control system. And partway through the project, the people who ran the source code control system said, guess what? We're going to charge you going forward to use this system. And they had all their code over here and everybody was using it. And all of a sudden this place said, okay, now it's going to cost you money. You're going to have to pay us X amount per month to keep using. That didn't go over very well. So what was the response to that? Exactly what you would hope. The team decided to develop their own source code control system. And the system they came up with is called Git. And Git has become pretty popular as one of the standard source code control systems. A lot of places use it. WSU uses it. It's used heavily in industry. I use it in my personal research. And it's just become kind of, not quite a de facto standard, but it's one of the more popular platforms. It's open source, right? It's something that you can run in your own directory, on your own machine, or on the Linux server, and have a local source code control system. But there's also things like GitLab and GitHub that are cloud-based services that will store your repositories for you off-site. So GitHub has been bought by Microsoft, which caused fear and panic throughout the community. GitLab has not. I like GitLab. They're both free and available for free use, but GitHub did not allow you to have private repositories for free. By default, your repos were public, so anybody could look at them. GitLab doesn't have that restriction. You can upload your information and keep it private.
If you verify as a student, you can get something like 10 private repos.
Okay, cool. So student options, which is nice. So I mostly use GitLab, and we're going to talk about Git and GitLab. But if you prefer to use GitHub and you have private repositories, that's fine. But if you're working on PA3, don't push your code out to Git on GitLab in a public repository. because anybody can go and look at it and pull down a copy of your code, and that's just not good. So, so private repositories, right, or stick to GitLab or something. All right, so that's the setup, okay? And Git is basically, the idea is you go through some initialization. The initialization can be kind of painful. You have to set up an account. You have to, maybe install the software if you don't have it, but it's installed in Linux by default. And when you start a new project, you have to do some one-time setup. It's a few commands. But once you've got all this stuff flowing, the basic setup is you write your code, and at some point you can say, okay, I want to add these files to the repository. So you've modified 3 files, you say go ahead and add those to the repository, and then you can say commit my changes, and those changes get recorded in this central location. And then you just go on, you keep modifying your code, and when you've made some more changes, you can say, okay, go ahead and add this to the repository, commit the changes. Okay? If you're using GitLab or GitHub out in the cloud, there's a push command. You can say, take my current view of my repository, push that out to the cloud. And it's one command. And you can bundle these commands into scripts, for example, things like that. And so it becomes second nature once you're used to it. But it's a habit, right? It's like making backups. But for me, I just have a few shortcut commands. I have something called push. And it automatically adds all my changes, commits them, pushes it out to the cloud. And I go to my other machine, I can just say pull, and it does the opposite thing, pulls everything down from the repository. And I do my research on a server back on the East Coast, and that's how I keep the code in sync. I modify it on my laptop, I say push, I log into the server, I say pull, and everything else is done. And if anything ever happens, if my laptop crashes, right, if the server crashes, all the code, all the data is stored off in the cloud. I don't have to worry about it. And if I decide that I want to use some other system and I don't have my laptop with me, right, I can make a new copy of this and just pull down all the code. So it's a really nice modality to get into. And so we want to get fluent with using Git. All right, does that make sense? All right. So let me switch gears on you now. Let's let that sit for a few minutes. And let me talk about command line arguments. All right, so here's a script called try. It reads a number, and then it prints out twice that number. So enter a number, there's 45, and it prints out a 90. We've already done this, right? Okay, so this is called a runtime input, because once the program is running, I type in the input. But it may be that we want a program that we can specify some input on the same line as we're specifying the program. Right? For example, when you edit a file, how do you do it? You say vi space file name. Okay? If that was a program input, you would say vi enter, and it would say what program do you want to edit, and you type in the file name, hit enter, and then it would open it up. Not quite as convenient. So when you say vi space program name, right? Program name, that's one of these command line inputs. So let's see how to do that in Bash, and it's really easy. If I say $1, that's a special variable, right? $n is the value of variable n. $1 is a special variable. It's the variable whose value is the first command line argument that you specified. So here, instead of saying read n, I'm just going to say n equals $1, and I'm going to print out 2 times n. And over here, instead of just saying try, I'm going to say try 45. And it prints out 90. And I'll say try 7, and it prints out 14. And I'll say try -8, and it prints out -16. So this $1 is a special variable that matches whatever the first argument is on your command line. Now if I just say try, $1 is blank. And so when I try to convert it to an integer, it becomes a 0, and I get my 0. But let's make this a little more interesting. I'm going to just break an echo statement which says $1 equals, and I'm going to show the value of $1. And I'm printing $1 inside these angle brackets because if it's blank, I want to know, is it blank? Is it a space? Is it 10 spaces? I want to actually see the beginning and the end of this $1. And if I just print $1 equals $1, if it ends with spaces, I'm not going to know if I'm seeing spaces or how many spaces. So a lot of times when you're printing things, to understand them, put them inside delimiters like this. So let's just try this. So try haha, $1 is haha, no spaces. If I just say try, $1 is just an empty thing with no spaces. If I say try with a bunch of spaces, $1 is still just this empty string with no spaces. And if I try this is fun, $1 is the word this. So it's picking up the first command line argument. So how do you think we pick up the second command line argument? $2, right? Does that work? We could go Google it. We're not going to Google. We're going to write some junk code. Let's just print it out. So first argument is this, second argument is. So let's print out the first 4 arguments. This is fun, and the fourth argument is just empty. What if I throw a bunch of spaces in here?
It's going to register. Oh.
It's basically ignoring the spaces. It's using the spaces to say what's the first argument, what's the second argument, but it doesn't care how many spaces are in there. So the first argument is this, the second argument is, and all those spaces in between are just delimiting the first argument from the second. So I'm hitting some tabs here, and it seems to ignore those tabs. This may or may not always be the case. What if I say this is fun inside double quotes? So if you put something inside quotation marks, that whole thing is treated like one command line argument. So that can be useful. All right, well, it might be nice to know how many command line arguments we have. And we can't necessarily just look for the first argument that's blank, because I might do this. And now my first argument is blank, but the second and third arguments exist. So there's another special variable called $number. And $number will tell you how many command line arguments you have. So if I say try with these 3 arguments, it tells me $number is equal to 3. Right, this is fun, $number is equal to 3. Single quote or single argument inside quotation marks, this is fun, $number is equal to 1. So we can start parsing command line arguments using $number and $1,2,3,4. And so if we wanted to write something that, read an integer and multiplied it by 2, we could say, is there exactly one argument? We could check $number, see if it's equal to 1. And if it is, then we know $1's the first argument. We could take that and we could multiply by 1, see if it's equal to itself or something to see if it's a valid integer, and then we could go on from there. And there are all of these $sign variables inside the shell. So $number is the number of args. $1, 2, 3, and so on are the actual arguments. Yes?
Are there 9 or however many?
However many you need. They just keep going. Another useful one is $? So let's look at $? It's equal to 0. And as many times as I do this, it's equal to 0. But if I do something weird that generates an error message, and then I look at $? It's non-zero. So $? is giving me the return value from the previous command. Now usually in Unix, if a command succeeds, it returns a 0. 0 means success. If it fails, it returns something non-zero. So if I echo $? Now it's a 0. Why? Because the previous command was an echo statement and there were no errors generated. And so now the current status is a 0. If I do an ls and I echo $? It gives me a 0 because the ls command succeeded. If I say ls try and I echo $0, $? I get a 0 because ls try succeeded. If I say ls haha, there's no such file, and now if I look at $, it's non-zero. It tells me something went wrong with the ls command. So we can write scripts that execute commands and then tell us whether or not that command succeeded. So that's $? $$ gives me a strange number. But over here it gives me a different strange number. 27,151 versus 27,166. Any guesses? And if you try this, you'll get a different number. In fact, any process that looks at $, will get a different number from every other process.
Is it a random number?
Sort of.
Processor?
It's a process ID, right? So it's a unique number that identifies each process on the system. And, well, let me do this over here. The PS command says, show me all my processes, and here's process 27,166. That's a bash shell. It's the other bash shell. And here's process 27,151. That's the bash shell I'm currently sitting in. And 27,151 is the parent of this process, which is the PS command that I just executed. So all of these processes have a unique ID associated with them. They remember the ID of their parent, which means you can trace the lineage of processes all the way up to the original process, right? The mother of all processes, which is a thing called a init, which is process ID 1. So we'll spend some time looking at process structures in Linux. But if you need to tap into your process ID, $, gives you that. So the critical point here is just that these things that begin with dollars, a dollar followed by a variable name gives you the value of that variable. But all of these things, these are special variables. And so this is why if you do something like if $num equals $1, and you're hoping to tell if num's equal to 1, that's not what this does. right? This checks to see if num has the same value as your first command line argument, which is probably not what you're looking for PA1. So, and syntactically it's valid, right? It's not going to say syntax error, it's not going to say warning. It's just going to do what you're asking it to do, but you're asking it to do something different from what you thought you were asking. All right, does that make sense?
How do you get the N command line?
$N. But if n is a variable, it's a little tricky. But shoot me an email and I'll dig up a solution. I mean, you'd like to be able to say $N, but it doesn't quite work like that, but that's the idea.
What does $sign question do again?
$sign question shows you the return status of the prior instruction. So, since my previous command succeeded, it gives me a 0. If I say remove some file that doesn't exist, and I look at $question, it's non-zero. That means the remove command generated an error. So here's a main program in C. It doesn't really do anything except laugh in the comment. And then it says return 42. So let's go ahead and run cool. And then let's look at $sign question mark. Guess what? It's equal to 42. So my C program, and everything's a C program. When you say ls, when you say rm, you're running C code, right? Executable programs. Everything has some sort of exit where it comes back to the operating system, and those exits return a value. So my C program just explicitly says return 42, but I can pick that up looking at $sign question mark after I've executed cool. So now we can write C code and we can have it return values back to the shell, and we can use those. And that's going to be kind of cool. And remember, there's my value of 42, but if I look at this again, what's the value going to be? It's going to be 0 because it's a return code from the previous instruction, which was echo. And this gets a little bit engineering 270-ish, right? When we think about status bits, same idea. The status bits reflect the result of the prior instruction. So if you do something with those and you check the status bits again, it's going to be the result of that prior instruction that you just did, not the one that you had in mind. So this can be interestingly confusing sometimes. All right, we got 4 minutes to talk about all of Git. Can we do it? No. But that's okay. So there's a how-to page on Canvas. It's up near the top. And the beginning of it is, accessing the server, setting up your password, transferring files. But the second half of it is all about Git. So GitLab. And the first thing to do is probably go ahead, log on to GitLab, and set yourself up an account. Because you're going to need that if you want to push stuff out in the cloud. I'm not going to force you to use GitLab, but there's really no reason that I know of not to. Right? And so if you want to use it, go ahead and go to gitlab.com and just, new user, follow the sign, and you give them an email address, you pick a password and a username, and you're good to go. They send you a verification. You don't get spammed or things like that. And so you can read through this, and if you want to go through the initial setup, you can, but I'm thinking tomorrow what we can do is we can actually run through this live. A few details on GitLab, right? It's free. You get 10 gigabytes per repository, and there's no limit on how many repositories you have, right? Ergo, infinite storage for free. What's not to love, right? But you don't really want to just push pictures up there or something like that, because you can't just go there and click on it to see your pictures. But for storing projects, right, 10 gigabyte times infinity is a good amount. They do backups. They maintain this stuff on their server if something goes wrong. they have redundancy and so on and so forth. It tracks versions of your code. It tracks changes, right? And anything that you've pushed up to your repository is always available. You can go back 3 weeks and say, what did my code look like 3 weeks ago in the middle of the night when I had that brilliant idea? And there's a copy of it up there, right? And that's automatic. And it's all time-stamped, and you can compare that version to another version and see what the differences are, and so on and so forth. And if you're working on a group project, right, you can start dealing with things called branches, where you can actually say, here's a copy of the code, and here's a second copy of the code. And you can start making one set of changes here, another set of changes here, and have 2 totally independent branches, or 3 or more. And then at some point, you can take these branches and merge them together, and it'll do some automatic merging for you, if you like, and you bring all this stuff back into a single branch. And it supports wikis, it supports task lists, all kinds of things like that. And it's a great thing to have on your resume, right? To have a link to your GitLab repo for some project that you've been working on. You can put that in your resume, and somebody who's looking at you can go right there and actually see your code, see what you've done, see your coding style, documentation, all that kind of stuff. And it tells a potential employer or institution, I know how to use GitLab. I've got good programming practices, things like that. So it's a really good thing to sort of like jump into sooner rather than later. I resisted it for decades, right? And finally sort of saw the error of my ways, and now I just love it. It takes away so much maintenance and hassle on my own. All right, so we'll play with Git tomorrow. We'll also do some flow charting. So bring something that you can write on, okay? Because I want to work on this in groups of 1 or 2 tomorrow, and have you do some flow charting. So bring something you can actually work on your desk with. And I will see you next time.
Do we have a daily programming assignment?
I will post one tomorrow morning, which will be due on the next day. And it'll be with command line arguments.